Hey everyone, it's Yash this side. I welcome you all to our next video of Flutter Bootcamp series. So in this video, we'll discuss about the Dart architecture. We'll see different types of compilations in the Dart language. We'll also talk about whether Dart is an interpreted language or a compiled language. So there's a surprise for you there. Also, we'll see some of the basic syntaxes in Dart. We'll talk about the memory management and garbage collection specifically happening in the Dart language. So yes, this video is going to be really very interesting. So you make sure you watch till this end. Also, one more thing. The prerequisite for this video is the video just before this one, the intro to programming video. So you make sure you watch that video first because I've created the dots in that video and I'll be connecting all those dots with respect to the Dart language in this video. So you make sure you watch that video first and then come to this one. Okay. So yeah, let's get started now. So let us start with some basic Dart programs so that you get more familiar with the language. So for this, let me create a folder first. Say Dart architecture. Let it be a file inside this named as syntax.dart. Okay. In the previous video, we discussed that any program starts with the main function. So let me define the main function first. So this is our main function. So in this part, we'll understand what are data types and variables. We'll understand what are data types and variables. Okay. So I'm just writing a simple statement first. Say int a equals to 10. 10. Okay. So what do you understand by this particular statement? Say, for example, see, my name is Yash. Okay. So this particular human's name is Yash. So in the similar way, this particular data, the particular number has a name A. And the type of this data is int. So the data type is int and the value is 10. A is the variable. Okay. So this is quite easy, right? So in the similar way, we can define other data types and variables as well. For example, double, double D equals to say 5.4.4. Okay. So this was to define decimal values. In a similar way, we can define a string, say as a name. Okay. In the similar way, we can also define a bool variable. This is for a binary data, true or false. Okay. We can write bool like React Native equals to false. So this was bool like React Native equals to false. So no hate to the React Native developers. Moving forward, we can define some other complex data structures as well. For example, a list of integers, say list of integers, say 1, 2, 3. In a similar way, we can also define a map of int and so yeah, this is it. So these are the most common ones which I use. There are other ways to define variables as well, and we'll cover these part again in the next video in a better way. This is just for so that we can understand the next part of the video better. So we'll cover these part again in the next video in a better way. So just move forward. Let's move forward. Uh, we can also write a print statement. See print a. So this is just to write anything inside the console. So if you run this program, we see a 10 since the value of a was 10. Okay. Also, the similar way we can see about a for loop. What is a for loop? So anything inside this curly braces will be inside a loop, will run in a loop. What do you understand by loop? Loop is something which will make it run again and again, right? So it works in this way that as it starts from 0 and it ends at 10. So there are total of 10 numbers in between. So anything inside this curly braces, the body, that will run for 10 times. Let me just simply take an example. Say print, say apple. Okay. If I run this one, let me just comment this out. I'll see apple for 10 times. So the apple got printed for 10 times. The apple got printed for 10 times. Okay. So this thing is for adding the iterator. If we can write it like this as well. If we do something like this, it will not print for 10 times. It will print for now 5 times. What happens is this will take the iterator by taking two steps like 0, 2, 4, 6, 8, 10 in this way. But it is less than 10, so it will just say till 8. Okay. If I now run this, so it just printed for 5 times, right? So this was about for loop. So I guess now we are ready to start with the main highlight of this video. So in our previous video, we discussed whether a language is an interpreted language or a compiled language. So now let us see whether Dart is an interpreted language or a compiled language and different conversions as well. To check, let's use the very similar example as the previous video. Let me create a file for this one as well. Say test.dart. Okay. I'm defining the main function first. Yeah. I'm having a variable called a and a equals to 10, and I'm just printing the statement. Say print a. Okay. Let me have one more print statement for a better visibility. Say print hello, and one more print statement with an error. So we are having b without actually defining it. Okay. So as per our previous video, if these lines got executed, even having this error, it is an interpreted language. But if it did not, it is a compiled language. So let's try running this out. Okay. If I run this, I got undefined name b, and these lines didn't get printed. So now you must say, so Yash, that is a compiled language. Okay, let's move forward. But here comes the twist. So actually, we can run a Dart program in two different ways. One is the compiled way, and the other is the interpreted way. And here's the twist again, but we'll get to that later. For now, let us see how we can run a program in both the different ways. Okay, so let me just remove this error for a while, and let's see how we can run a program in both the ways. So let's try with the compiled way first. So to do that, I can use the terminal and write the command dart compile exe and the name of the file. Test.dart. Okay, I'm in the wrong directory. Let me do a cd dart architecture. Now I can run the program. So as you can see, a .exe file got generated after writing this, and we can run this .exe file by this and the name of this. So you can see 10 hello and the space got printed. Now let's run this in the interpreted way. So to write that, we can use the command dart run and the name of the file test.dart. So yeah, 10 hello and the space. Okay. I guess this is clear. This is the interpreted way of running the program in the Dart language. Now let's come back to the errors. And now let's try running this in the compiled language. So we know the result for the compiled language, obviously, right? So undefined name B, this didn't get executed, the above two lines. Now let's try running in the interpreted way as well. So undefined name B, but oh yes, even in the interpreted way, these lines didn't get printed. How? So Yash, you said that in the interpreted languages, the program actually runs line by line, and according to that, this error will be diagnosed in that line, and these lines should have got executed. So the answer is these the program is actually running line by line only in the interpreted way, but the error is diagnosed while before running the file only. So the Dart language actually diagnoses any error before running the program and it diagnoses in the pre-processing step only before the compilation part. So I guess this is clear. Let me write it down as well. The Dart language, Dart follows check before you run. And in the previous video, we discussed about the JavaScript language, and JS follows check as you go. So JavaScript checks error while actually getting to that line. Like for example, after completing this line, and when it is coming to this line, at that time it gets to know that there is an error. Therefore, JavaScript didn't do the same behavior. But now you might ask, Yash, how can we see the difference between the compiled way and the interpreted way if this is the case? So I have a solution for this as well. So do you remember in a previous video I mentioned that the interpreted languages take more time to run, and the compile time languages is quite fast because the entire program is already in the machine code, and now we can run the program. So machine can understand it well, right? So let's do an example for that in the Dart language itself. So let me create a file for this one as well. Let this be speed.dart. Okay, so I'm defining the main function again for this. Yeah, and just let me write the program first. And sum equals to 0, and for int I equals to I is less than a huge number, and I plus plus. I can do sum plus equals to print. So what I'm doing over here is I'm defining a variable sum, and using a for loop, I'm just incrementing sum by 1. Okay, and I'm just printing this. So let us check this program by the interpreted way and the compiled way. How much time will it take? To see the time, let me define a timer as well. There's a function called stopwatch. Let me use that. Okay. So final timer equals to stopwatch dot. This will start the time. Okay. I've started the timer. After doing the entire sum, let me stop the timer. Timer dot stop. Just here should be two dots. Okay. So let me print the timing as well. How much time did it take to run the program? So timer timer dot. We are printing that in the milliseconds. Okay. So let's try this program in the compiled way and the interpreted way and see how much time will it take. Okay. Let's try with the compiled way first. So dart compile exe speed dot, and we can run this dart file by speed dot. So it took 51 seconds. Let me increase the zeros so that the difference is quite noticeable. Okay, I've increased two zeros, and let's try running this program now. I'm compiling it once again and executing. Okay, so it took 3873 milliseconds, the compiled way. Now let's try with the interpreted way. Let me write dart run speed dot dart. So you can notice it took 5545 seconds. So this is quite more than the compiled way, right? So yeah, this was the difference I was talking about. You can check this number in your machine as well because my machine is quite strong, so it took less time. The Dart virtual machine is running quite well in my machine. So the time is quite less in my case, but it can differ in different machines. So I'll write it down the time it took in your machine and let me know in the comment section. Okay. So I guess this is clear. Now let's see what shall we actually name the interpreted way and the compiled way in the Dart language. Okay. So let's move to the interpreted way I was talking about, that is called just-in-time compilation, whereas the compilation style I was talking about, that is called ahead-of-time compilation. So in the terminal also you must have seen AOT compilation error. So that was about this one only. Okay. So let's go towards the points as well. So just-in-time compilations happens at the runtime. The primary use cases, development and testing for rapid iterations. So yeah, this is something which makes Flutter a bit more special because it gives us the feature for hot reload, which means even if you have any small change in your app, you can see that instantly in the UI or in the app itself. Okay, so yes, store startup time as the code is compiled on the fly. Yeah, already we saw that. So yeah, runs from source code.dat using a virtual machine. Okay, so in ahead of time compilation, it happens at the build time. The primary use case is production and release for the final app. So yes, when the entire app is programmed or coded, and when it is ready to deploy it on the Play Store or App Store, at that time to generate the build file, we use the ahead of time compilation. Okay, so yeah, faster startup time as the code is already native and executes immediately. It's already in the exe file. So yeah, it generates faster. Creates a self-contained native executable file, a .exe file, .apk file, etc., whichever IPA file. So yeah, this is about it. And you can probably share this on your LinkedIn and Twitter that you learned about just-in-time compilation and ahead-of-time compilation. You can mention me over there. And yes, let's move to the next part now. So now let's discuss about the Dart architecture. So you must have heard me saying something called as a Dart virtual machine. So what do I mean by this? You can think it as a machine or probably as an engine whose job is to run the Dart code. What did I say? You can think it as an engine whose job is to run the Dart code. Okay. And there are other several components in it which actually helps it to do that. So we have memory heap. We also have a garbage collector. We have JIT and AOT compilers, which we just discussed. Also, we have something called as a isolate manager. Okay. So let's now first understand about the memory part. So in our previous video, we did discuss about something called as a stack memory and a heap memory, right? And we also discussed that if you want to store something big or complex, we store that in the heap memory. And if you have something simple or small, we store that in the stack memory. But what happens in the Dart language? The Dart language says that everything inside Dart is an object and everything will be stored inside the heap memory only. So if you have something like int a, and if you want to we want to assign some value to this, there will be an object created in the heap memory like this, and the particular address, for example, address xyz at which the object is getting created, that particular address will get stored inside the stack memory like this, like this. Okay, and this object which is getting created, it also has an object header. You also have something like this, a header, object header. So this is the object header which actually contains the metadata about this object. For example, the size of the object, the data type it belongs to, and probably some other details as well. Okay. Also in this statement, in place of int, we can have any data type. Okay. We can have any data type in place of int. And as I said, everything is stored inside the heap memory. We have a small exception over here called as a SMI, very small integers. So that is used for iterators. So that is stored inside the stack memory only. So but in general, we say that everything is stored inside the heap memory. Although we do have an exception called as a SMI that is stored inside the stack memory. So I guess this is clear. Uh, so now let's see about the garbage collector. So what do you understand by the term garbage? So it simply means any object which is unreachable. So now you might ask, Yash, what do you mean by unreachable? So it simply means that any object which do not have any particular reference variable. So see, to access any particular object, we do need a particular reference variable. And if we do not have this reference variable, we cannot access this particular object ever again. And if we do not have this reference variable for any object, that particular object is called as a garbage. And that must be removed by the system. So Dart has a very unique way of handling this, and it has a very unique way of memory management. So it has something called as a young space and a old space. So Dart divides the memory into two spaces. First is called the young space, and the second one is called as a old space. Let me write it down as well. So the first one is called as a young space, and the lower one is called as the old space. So actually, the young space is, you can understand it this way, that anything which is quite temporary to store, that is stored inside the young space, and something which is quite permanent to have something in the entire life cycle of the app, that is stored inside the old space. And let's have an example as well to understand the garbage collection and this memory management in a better way. So take an example that you are using a social media app, or probably you're building a social media app, and now you are just trying to open a profile of a friend. So let me create a reference variable for this as well. Say friend profile, and see the friend's profile data is quite a temporary data for us. We don't need the friend's data again and again while we are using the app, right? So that will be stored in the young space. And see what is happening when we are clicking on the friend's profile and the page is getting appeared. We're actually creating an object for this particular friend. And this object is accessed using this particular variable friend profile, right? And now when we are all done with we are all done, we go through the friend's profile. And now when we are pressing the back button, what is happening? We are deleting this particular reference variable like this. And now when the reference variable is gone, this particular object in the young space has become a garbage for us. Because if we ever want to go to the same page, the system will create again a new object and that will be referenced by new variable as well. So this particular object has become a garbage for us. And this will be seen by the garbage collector and will be removed. Cool. And for the old space, you can take an example of yourself, the user profile data. So that will be required again and again while you're using the app, and that can be stored in the old space. So this was about this one. We'll again understand these things when we will study about state management. For now, let's move to the next part and let's carry on. So next we have JIT and AOT compilers in our list. So we have already discussed about both the compilers in very much detail in a previous section. We also saw the difference between both of them, right? But if you want to understand the internal working of the compilers, you can probably go through some of the articles or the GitHub repository, or you can let me know in the comment section as well. I'll probably make a dedicated video on this in future. But for now, it is out of scope for us. Okay. So, and next we have isolate manager. So this is an entirely grand, interesting topic which is about isolates. So you can understand isolate as the Dart's version of thread. and every isolate has its own memory heap and they communicate via messages. Or you can say have a mailing system that through which they communicate. I will understand this when we'll study about asynchronous programming, the async await keyword and the future keyword. Okay. Uh, but for now, this is it. We'll start with the programming part in the next video. So make sure you subscribe to the channel so that you don't miss out on that. Also, you can like this video and let me know in the comment section how was it. And yeah, thank you so much for joining. I'll see you in the next one.